Hello and welcome to an FPGA vision video. In this video we look at VHDL simulation of the video generator that we use as an example for beginners in VHDL and FPGA design. VHDL simulation means that you simulate, operate, execute the functionality of a VHDL design on a computer. And you do this with a simulation program. In our video we use Questa, which is part of the Altera FPGA design suite. The circuit that we want to verify is referred to as the design under verification. And what we also need is a test bench. The test bench connects to the design under verification and it provides the input signal to the design, the stimuli, and it receives the output signal, the response. The test bench, like the circuit, can be written in VHDL. The installation of the Questa simulator and the Quartus design suite is described in a separate video that you can find on the channel. The design of the video generator is given on GitHub, and in the subdirectory VHDL you find the test bench sim video generator simple. You have an entity that is empty because it's only for simulation. Then you have signal definitions, and here you have the clock generation. We use a clock cycle of 10 nanoseconds, so 5 nanoseconds low, 5 nanoseconds high, because that's easier for calculating clock cycles. Then you have here the design under verification, which is invoked, instantiated as a submodule. And then you have control of the stimuli signals. Reset is applied, enable input is set to 0, we don't use that. We wait a little bit and then we count for one video frame. One video frame is 1650 pixels per line, 750 lines, so we count that number of clock cycles, and when this is complete we stop the simulation. So very basic functionality of this test bench. Now we use the Questa simulator. We have a project which contains two source files, the design under verification and our test bench. We compile everything and then we invoke the simulator. And here's the user interface for our simulation. We have here the input signals and output signals. We want to monitor those, so we put them into the waveform. And we also want to have a look inside of the design under verification. And we want to monitor the horizontal count and the vertical count. And with that, we now start the simulation. We simulate it for 500 microseconds, which is several lines. And we press run and are completed very soon. You see the clock here. You see the different signals. We want to zoom out a little bit. So now you see here one line of video. This is the data enable, which indicates an active line. And we can check if the line has the correct length. So we take our first cursor, put it to the start of DE out. Then we add a second cursor and put it to the end of DE out. And we see that we have a difference of 12,800 nanoseconds divided by 10, because one clock cycle is 10 nanoseconds. We see that we have the correct length of our data out. The same we can check for one line. So from data enable to the next data enable. This is 70,500. This is also correct. This is the number of clock cycles, 1650 we want to have for one line. So this looks good. We see our design is working. Also we see the output here of our video. Red, green, blue is 80. So this is the gray output we want to have. But it's very difficult to see the complete image in this format, but still it's a good start to see that we have the control signals and that we have certain values here. To visualize the output of the video generator, there is a second test bench, which is also provided at GitHub. This one is a bit more complex, but you don't need to write the test bench. I think understanding it and reading and using it is quite feasible. So it's called Sim Video Generator Image File. The start of the test bench is exactly the same. And at the end of the simulation, we have here a signal end test bench. And then we have a second process for handling, for observing the device under verification output. We open a file, we wait until we have started the video generation, the first horizontal sync, and then there are some print commands. So we write a header into a file, and then we have a loop here that runs until this end of test bench, and then for every data enable we get the red, green, blue information from the design under verification, and we also write it into a file. Then we close the file, and this is the end of the test bench. We can simulate the test bench with Quester again. When you click Run All, you simulate for one complete frame, and then we get this output file. It has the header, and then for each output pixel we get one line with the red, green, blue values. This is a very inefficient format, but with Irfan View we can display it. It's the PPM file format, and we can see that we have the gray background and two squares as intended in our design. We have now verified our design and can implement it on an FPGA. There are two videos available, one about implementing it on our remote lab and another one about implementing it on an FPGA evaluation board.